I prepared this talk for a meetup a year or so ago, and it was a very small version, but it had huge success. And I'll give you a link at the end so you can see like the first part essentially of this. And then after that, I created all new content and things. And the more I went on, the more I was creating slides, and I was like, this is not, I don't know. I don't think people are going to get it because it's too, in a way, complicated, although they're simple things, but I wanted to show them in a different way. So this morning, I decided to throw away all the slides that I've done, and I'm going to do live code instead. Because what could possibly go wrong, right? Like, it's going to be fine, absolutely. First, it's the first time that I do this, so be gentle, please. Second, there's a rule to this talk. So I don't know how it's going to work here, because you're all super silent, so we'll see. But every time you see something that you didn't know about, or used in a way that you didn't think about before, or whatever, you have to say, oh. Okay? Should we try? Okay. You could do better. It should be that loud that other people look at us like, what the fuck? Okay? Last time. All right. We can do this. We can do this. All right. Let me do presentation mode, I guess. Ah, can you see? No, of course not, because the display is not mirrored. What the hell? Why? Arrangement, mirror. Oh, and now I can't see anything. Really? Okay. Can you see now? Yes. Oh. You're getting it. Perfect. So, but this way I don't see the thing on the side. For fuck's sake. Oh, well. So let's do it like this. Why not? Yeah. All right, so let's start with something simple. Did you know that in Kotlin, packages are not tied one-on-one with the location of the files? This file here is, I don't even know where. Where are we? So it's in whatever, blah, 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 package 1, etc. All right? And in fact, if I uncomment this, it's not complaining. Okay. The point is, you can put whatever package you want here. And it will say, oh, but it's not in the right place. And you can just say, you know what? Shut up. Potentially commenting because reasons or whatever. But you should always leave a comment as to why. But this way you can pack features together, even though you might have to put files in a different package for whatever reason that is. It's amazing for hacks when you need to access protected methods of other libraries, which nobody ever does, of course. But yeah. So this is a simple one. Then let's go to the next. OK, so we have a very simple example. So if you look at these two methods here, they both take a generic number and print it. They have one difference, though. In the first one, the number is not nullable. In the second one, the number is nullable, potentially, right? So from the JVM point of view, there's no difference between these two methods. And in fact, if you show the Kotlin bytecode and decompile this, they're literally the same method. So we have a problem here, right? It turns out that the JVM is not smart enough, but Kotlin is. And so what we can do is to use JVM name, which is something that gives a method, a name to the whatever you put it on, and call it, I don't know, could be something like print number nullable. And then suddenly, it doesn't complain anymore. Yes, exactly. And I can even prove it to you, hoping that this, yeah, there you go. It will say non-nullable and nullable, despite the fact that they're the same number. Amazing. This actually does come up in real use cases, so it's a real thing. OK. While we're here, there's one thing that I wanted to point out. Sometimes you see methods like, I don't know, who, that are generic. See, that's why I want to live code, so I can tell you stuff at random. Normally, or sometimes you see something like any. And you're like, but, I mean, of course it extends any. Like, what else, right? But the truth is that normally the default, if you don't specify anything, is any nullable. And so by saying any, it means give me anything as long as it's not nullable. And it took me a while to figure out why they were adding this, so now, yes. All right, next. So 3, multi-part. Yes, okay. So when, not as a philosophical question, but as in the operator, when, suppose we have an enum class, right? Has 2 moods, happy and sad. We have a method to randomly get a mood with a specified seed, so I know already the result beforehand. It's cheating. So it's a non-random random, obviously. And then we have a when that is used as an expression, and it returns a string. So if the mood is happy, smiley face. If it's sad, frowny face. And if you run this, it will say happy face. Yay! Okay. Now this works, and if we add a new one, let's say meh, it will break. It will say, I'm not compiling. You need to add the other one. Why did you import? Oh, well. And so here we have to say meh, right? That's fine. But there's also, oh, no. There's also other cases where it's not that easy. So for example, if we go to 3.2, so suppose we refactor this code. We have the same method. We have still calling random mood the same as before. And in fact, if you run this, it works, right? Except now the when is not used as an expression anymore. And since it's not used as an expression, what happens is that if we go back and add another mood, this will break, fine, as we expect. Actually, let's, but the other one will not break because it's technically fine that, like nothing is expecting all possible cases to be handled, and so it can break. It's the same as if, if you use if or else as an expression. So I don't know, val a, if true, this, else, I don't know, 0, whatever. Here you have to cover all the cases. If you just say if, it won't work, right? But if you remove the val, then suddenly this is okay. So how do we fix this? Because many times if you use seal classes, you do want to be extra sure that all the cases are handled. But if you do something like this, whatever, 1, the name doesn't mean anything. 2, it will correctly say, oh, it's not used. And so the next person in your team comes and says, oh, look, I cleaned up. And then things start to break. How do we fix it? So one method that I've been using for a while, and it works really well, is the exhaustive thing. So it's very simple. It's put in the root package. By the way, if you don't specify a package, it means it's in the root package, so like a sort of no package space dimension. Interesting fact, it doesn't have to be at the top of the folder hierarchy. You can actually put this anywhere, and it won't complain, which is interesting. And so it's just an object called exhaustive with lowercase e. That's why we had to suppress the ID from complaining. And then we have one function that is an operator, the range2, the double dot. And we do something very simple. It's generic. We take whatever you put in and just return it. So we don't really do anything here. We just literally force it to accept something just so that we transform it into an expression. I've also made it inline and JVM static because I've noticed that by doing both of these, if you just use it the way it's meant to be used, Progar will completely strip it away. So it's a no-cost abstraction. And now, with this one, something magical can happen. So first of all, if you try to write it with autocomplete, it will find it, but it will not import it. It's probably a bug of the IDE, I don't know. But if you manually import it, then magic. Suddenly, you really need to also specify the other branch. What if I do this? No, it still doesn't work. Damn it. Well, and then, of course, you print blah, blah, blah. OK. Oh, come on. It wasn't that good. OK, OK. So next, seal classes. Seal classes are cool. One thing that not many people know is that you can have seal classes of seal classes, and they can have different level of nesting. If you have never used them before, the idea is you create a seal class. It's just like an abstract class, except the direct children have to live in the same file. And the children themselves, they can be anything. They can be abstract classes. No problem. The point is, you'll be able to extend child A, but you will not be able to extend parent 1 from outside of this file. And that's OK. So yeah, normally you see seal classes used inside. Something like you do this, you put the child in, right? The trick is that they can also be outside. And that actually makes it a lot nicer when you have a lot of nesting and a lot of hierarchies. In this case, for example, oh, and you can mix and match. So in this case, we're having like one parent inside has child A and parent 2. And the second parent inside has child B and parent 3. And then the third parent inside, both as a hierarchy and physically, they are literally inside the class, has 2 other children. Now, the interesting fact and why this is so damn useful is that when you go to a when and try to expand on, match on the cases that you're presented with, check out what happens. It will automatically find all the leaves of the hierarchy and present you exactly with those. So even though it's a very complex hierarchy, you can still use it as if it was flat. And it's even better than that, because if you take something like parent 3, so instead of child C and child D, if you say parent 3, it will be smart enough to understand that it won't. By the way, this is something that we'll see. The difference between object, which is a constant, so you don't need the is check, because it does a reference check. If you put is, it will do instance check, like checking the class, etc. This only complains because we are doing the to-do, which returns nothing. Apart from that, it won't complain. So this way, even if we move the case up, it knows that it can only be these things and nothing else, which is so good. Or you can do the opposite or whatever. But in any case, if you do a combination that makes sense and you covered all the cases, it will know and it will work. So way to go. Yes. Next. So how many of you are Android developers, by the way? Oh, surprise. Wow. Okay. How many times have you created an adapter from scratch? So you do the usual thing. You create a class, etc. And what happens is, OK, fine. There's methods I need to implement. Fine. You do this, and you get this. Like, oh, shit. No. Damn it. I was too good. I imported the nicest library. Damn it. Yeah. OK, imagine, because that's actually what happens, that this is called like P0, P1, P0, etc., etc., etc. That plus this comes from Java, which is the reason why this normally sucks. Like if you don't have the sources, the IDE will not know what names to give, and it will just give random names, right? So you won't get anything. You won't necessarily get nullable, not nullable. You don't know. But let's say that it's not idiomatic. What if there was a way to make this better? There is. So the idea is that, oh, sorry. Yeah, what did I do? 5, are we here? Yes. The idea is this. Suppose you create an interface that, wait. Hey. you create an interface that has the same signature as the methods you are trying to override, okay? And nothing else. So if you look at the Java implementation, it's literally this, with these names, by the way. And I even added a twist, since I every single time forget that in the create view holder, the int is a view type, and on the position, I made it a type alias, or alias, no, alias, I think alias. So when I look at it as, I look at the signature, I'll see it's a view type, despite the fact it's still an int. Fine. But this is an interface. We cannot do much with an interface. Well, maybe we can. So what happens here, let me do it this way. If we comment these lines, it will say it's not abstract, exactly the same as before. And now we add this, and notice that we added before the other class. This has an importance, at least in Kotlin. Now, when we go and say implement members, we are going to find these three methods before the other ones. Like, you can still choose to override whatever, because in the end it's text, and the compiler will not complain. But by default, you get prompted to override the Kotlin signature of this. And just like that, automatically, you get all the nice types and all the things formatted in a really nice way. So this is really cool. Then, this is the moment when you do, oh. Was there? Yes. The fact that you can merge interfaces with classes has other benefits that sometimes are almost scary by how cool they come out. So another example. One thing that I found myself doing over and over and over was in adapters, I wanted to keep a reference to the recycler view. And you don't get it for free. You get these two methods, on attached recycler view and on detached from recycler view, where you have the opportunity to save it somewhere, and then of course make sure that you remove it after. Okay. So this code, I was copying and pasting it over and over. You could create a base adapter, but sometimes you can't do that because maybe you're using an adapter from different library. The fact that it's an abstract class makes it really hard to compose, right? What if there was a way to make it composable? Well, let's try. So again, we do our nice interface, and this is always the trick, right? We have an interface that exposes what we would want to have. So we have these two methods, which again are exactly the same. And I like this as a good practice to always link when you're overriding something to explicitly say it and link to it. So you can also, if you want, jump directly to it, which is not bad. And then we expose this val recycler view, which is nullable because it might not be there yet. Then what do? We create an implementation for this. So not even a class. We literally create, we create a function that creates an anonymous object that implements our interface. And so if you look at the signature of the class, oh, by the way, I don't know if you knew this. If you have an object that implements an interface in a simple way, so without mixing different interfaces, etc., that it will be casted as the interface, despite the fact that this is technically a different class, but it's smart enough. So it's just a base interface. In the interface, we do exactly what we were doing before, but this is just outside of the recycler view. How are we going to do this? So two things. So let's do this. We have our adapter as before, but now we add this. We say that this one implements the interface by interface delegation, calling the function. By calling the function, we generate the object, and then the object is used as a delegate for that. And this works. And in fact, the IDE will say, oh my God, you're overriding something. Yeah, that's exactly what I wanted to do. So shut up. And we also explain why, because we're nice. If you don't believe me, I can show you how this works behind the scenes. So what you get, this is the function returning the anonymous class. Okay, nothing weird. But in the actual adapter, See how we have this delegate 0 field, which is the delegate we end up creating. And in fact, it's literally inlined here, the function. And then it just calls the delegate all the way. As easy as that. Interface delegation is not a new concept, and it's cool and everything, but it's normally very limited because not many things are interfaces. But by using this trick, you can sort of make your own interfaces out of concrete objects that have multiple things inside. And so suddenly you can treat an abstract class as if it was a composition of interfaces, which is amazing. All right. Okay, yes. So, boop, boop. And now, no, we're already here, so 7. Oh, yeah. Interface delegation can be tricky, though. I'll show you this. Oh, actually. You might be tempted, and I've done this in the past, and it's cool when you can make it work nicely, to be a collection by delegation. It can be that you have some object that contains, I don't know, for example, you have a feature flag manager, something that I did, which is a collection of these flags, on, off, etc. And normally you access it by calling something like give me the flags you have inside, blah, blah, blah. But this way, you can actually make the entire thing the collection of what it is, like a smart collection, which is really cool. Except there's one problem. So let's wait. It is too good, and it does things. Let's play a game. We have these two lists, which are the same objects, but technically different lists. So it will print them. Actually, let me show you how they get printed. But then I ask you, what is the first line going to print? We are doing a reference check. So are they literally the same instance? And the second check is, are they equal? So what do you think about the first one? True? False? In between? What was? So if you said false, correct. And this one, true? Not many hands. False? No one. Okay. See, you're playing safe. It's actually true, because collections are on the JVM or in the JVM framework, whatever. When you do equals, they actually go element by element and check if things are the same. Cool. And I didn't show it here, but if you put them in a map where hash code is important, the hash code is actually based on the contents of the list. So, right. But then suppose that we start creating our own thing that just wants to be a list, but has some steps to do still. So when we print it, let's start from this actually. What do you think will print? Well, okay, that's hard to assess, but think it in your mind. And if we run it, even just from the list, you'll see that something is not quite right. This is the standard toString you get from any object if you don't override it. Because technically, and this is the whole point, we are overriding the interface list. But the interface list doesn't include toString, it doesn't include hash code, it doesn't include equals, etc. Actually, fun fact, if you try to add those to an interface, it won't let you, because there's something that is not supposed to be in an interface. Apparently, I don't know. Okay, then. Is thing the same instance as thing? True? Okay, 2 hands. False? No hands. This is not how you play the game. It is the same instance. That's one basic rule of the JVM, unless, I don't even want to say the alternative. Are they equals? True? Every time there's less hands. False? Okay. It is true, because by default, an object, if you don't override anything, and it's the same instance, then it's also equals, which is fair. If we created, for example, a second thing, now that I think about it, and even with the same list, and you try to compare them, by reference and by equals, actually that would be a different outcome. It will be false in both cases. Because again, it's by default, it just checks, are you really the same thing or not? And then the last part, is thing the same instance as the list? And is thing equals to the list? This is where it's really important to know the answer. I'm not even going to ask. The answer is neither. So the point is, while the lists are equal, just by delegating to the list interface breaks this contract, which is very important. So if you ever want to do this, you need to do something like, you need to keep it potentially hidden, because probably that was your intention since the beginning. You want to override equals hashcode into string, and then each one of these, you essentially want to, why are you not doing it? Boo, you made me sad. All right. So let's do plop. Instead of super, though, really? Come on. We are going to call list. Yeah. List equals, this will say, oh, you can use the thing operator. Cool. Hashcode and to string. And now, if we try this again, dun, 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 magically, it behaves exactly as we would expect. So don't do hash code, kids. I don't know. All right. Was that the last one? Let's see. Oh, yeah. Yeah. So cool, all good. Yeah, but there is one problem. Wait, were we on this file, or is it 60? Yeah. So there is one problem with objects that I discovered with my team in a very painful way, because it started exploding in production. And that is, have you ever tried to make an object serializable? I mean, why not, if you think about it? Actually, wait, I don't want to be there, because then I'll spoil the surprise. So suppose you have an object of any kind. It could be even, whatever, a simple object. I'm simple, OK? And you make it serializable. It doesn't have any fields inside. Why shouldn't it be serializable? And in fact, it is, easily. We can even test this. And if you serialize it and deserialize it, it correctly produces an object, I'm simple, with one small difference. It's not the same object. So we assume that objects like this top level are all singleton, and they generally are when they are created normally. When the serialization mechanism recreates the object, it calls internally its own constructor and creates a new instance, although it shouldn't do it. And so this is something that happens, and you need to be aware of it. How do you fix it? Well, there's one way. It's not too pretty, but it works. Yeah, so this is to show you how we can check. If you take a serializable, you can make it a byte array by creating a byte array output stream, and then object output stream. You use it, blah, 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 blah. Yeah, whatever. And the other way back, still, blah, 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 input stream, etc., etc., etc. And then we cast it because we know it's a real thing. OK. And then we check. We have the one object before, and then after, we just serialize it and deserialize it, and then check. Are they the same instance, and are they equals? Let's see. And you can imagine our expression when suddenly, like in production, we clearly figure out that there were two objects that were supposed to be the same. Like, parallel universes, what? So one trick we came up with is, because again, the only way to fix it is by playing by the rules of the serialization mechanism, and that is like this. You have this read resolve, which is a magical method that whenever you have it on an object, it will be called whenever the serialization happens. and you have the chance to return a different instance than yourself, which is exactly what we want in this case. So ideally, if we just made an object with this, I'll show you. So we have this D1, and then we say, okay, when there's read resolve, yeah, sure, we return this. And by calling it explicitly here, we are essentially using the proper system and referencing back the singleton object that we expect. If we try it now, it still doesn't work. Nice. Why doesn't it? Maybe because the signature has to be like this. Yeah, yeah. And in fact, before, it was not used. And suddenly, as soon as we match the signature, something is using it. But then you're like, oh, cool. Find usages. No usages found. It's a ghost. And if we try it now, then it works. But this is just so cryptic and unreadable. So we said, what if we had a way to, at least provide a way to show that it's intended and why, etc. So the idea is creating this interface that has this method so you cannot get the signature wrong. Not that anybody would ever do that. And then we just have a very, tricky thing. So this is a lambda that takes no parameters and returns our interface. On the lambda, we create a val extension called asReadResolve. So essentially, on the lambda of that interface, you'll be able to access this val called asReadResolve. What it does behind the scenes is that it returns an object that does all the things, and when you call invoke, it will actually return that from read resolve. I'll show you how to use it, but the idea is, so we have this, the one, we remove this. Instead of serializable, we can use serializable, but the other one extends serializable directly. We can say serializable override by the one as read resolve. Weird, but it works. And this way, anyone new to the team is going to see this and be like, what the? But they'll be able to jump in and see why and how it works and be like, oh, I still don't get it, but oh, okay, sure. And they won't delete it, and they won't, break it, etc. Blah 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 blah. Plus, this is also like a, you're really, really telling the entire system. You can even search for references of this, like, you're encoding it as an intended behavior. Fireworks, yay, that's the spirit. Okay, so next, where we, let's say 8. How much time do we have, by the way? Not too much, okay. So, objects can do a lot of things. So for example, you can use them as containers, which, my things. And then inside you have something like val A, val B, etc. And the point is that you can even put functions. And whenever you are in any external function, whatever, instead of having these at the alternative of not having it an object would be that they will be top level. And then suddenly in your global scope, you have this pollution of all the things being there all at the same time. You have no context as to why they're there, and do they refer to the thing I'm thinking about? Maybe, maybe not, I'm not sure. But this way, they're just neatly, encapsulated, and you can just say, oh, my things dot A, B, hello, etc. So this is one way to use them. The other way is to use it as an extension point or an anchor, if you will. So suppose you have this my things, and for example, you are a library author, and you just expose this object, and you say, every time you want to extend my library, use this as the extension point, despite the fact that it doesn't contain anything, but it's just a marker to namespace something. And so you import the library, you use it, and then you say, oh, I want to add to it. And so you're going to say, like, fun, my things, blah, and then suddenly you have your own function. And suppose that the library did the same. So this is not lib, this is lib. And the library does exactly the same, except they write blue. This way, both the library and the non-library, so the user code, they are put together in the same space without extra privileges or anything like that. And suddenly, when you reach for the extension point, you have everything. It doesn't matter what package is in. It doesn't matter if it comes from the library or from the user code. It's still in the same thing. It's easy to do this on existing instances and classes, but to do it on a specially created marker is an interesting thing that really helps when you want to namespace something. Blah, 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 blah. Yeah, then something that might seem trivial, but just to make sure that you know, are objects types or instances? Types? Instances? Both? Neither? All right. So if this was an instance, then we would be able to call methods on it, I guess. So like this, or yes, so I guess it is an instance after all. And what is the type of this instance? Well, it's itself. So objects are both a class and a single instance of that class in a very, very similar way to unit. Unit is exactly the same. It's a type, yes, but it's also a thing you can return from functions. So it is absolutely equivalent to say this or to say unit. You can do it, and you can even use unit as transformed by the compiler for things that are from Java. So if you say Java lang whatever system, yeah, no out, oh my god, yeah, print line, yes, and you print something, this returns void. You can even check it out. Yeah, it's void. But still, this works, and the return of this is unit, right? So that's it. And one thing that I didn't think was possible for a very long time, because it turns out there's a bug in IntelliJ that doesn't let you do it automatically, is if you have a function inside an object. I'm a ninja. You would think, oh, this function is only accessible inside the object. So to use it, I would have to do something like with my things, and then inside this lambda, this is my things, and so then I will be able to say, I'm a ninja. Okay, it's a bit convoluted. It turns out you can say, I'm a ninja. Here it won't show up, but if you import it manually, so if you say, import my my things dot I'm a ninja, then you can use it. Yes. Yeah, other silly things that are, again, they are obvious once you see them, but maybe you haven't seen them before. Objects don't have to live outside. They can be anywhere. So objects can definitely be inside classes. Foof, and then you have object bar. And then inside, you can have another one, etc., etc. And you can have as many as you want. OK? Etc., etc. And this brings us to the fact that companion objects are not special by by object standards in that sense. So if you create a companion object, normally you would see something like this. Few things. One, if you put it at the end especially, you can have it without the brackets, which is nice. If you put it at the top, it tends to get confused with the lambdas. It depends. Sometimes it works, sometimes it doesn't. You can give it name. So this can be, sports bar. And then suddenly, when you create extensions for this, that you want to be at the top level. So there's a difference between saying fun foo.hello, because you need an instance of hello to call this, right? So imagine you have something like this, and then, oh, sorry. So you have an instance of foo, and then on the instance, stop it. On the instance, you can say, well, hello. But what if you want to do it at the top level, like foo dot something? Well, then you need to extend the companion, which by default is called, where are you? Companion, capital C. Then suddenly, if you do this, this doesn't work, but you can do foo dot hello. What happens if you change the name of the companion? Unfortunately, you also change the name of the extensions, which is really bothers me, but that is what it is. So sometimes you just need to know about the companion of an object. There's nothing else you can do about that. I don't know if they're telling me, oh, 10 minutes? So, a confusing number of minutes. OK, perfect. OK. I'm going as, I have a lot of this. Yeah, and because they are just normal objects, they can extend anything. They can extend interfaces. They can extend classes. There's no reason why you can't say this one extends, I don't know, activity. No, I'm kidding. Don't do that ever. Seriously, don't. But it, you can. Technically, you can. All right. Then, so overloading operators. Yeah, you've probably seen tons of this already, but there's the usual ones, etc., blah, whatever. There's a few tricks that I learned which are really cool. So if you start writing operator fun, and then you say, oh, please, can you autocomplete this for me? Oh, actually, it doesn't work now. Interesting. Well, let's say, I don't know, string dot, check this out. See that it's actually telling us all the operators you can use, which is really cool by itself, because I never remember the syntax that I have. So, cool. That's one thing. Second thing is, one of them, it's rarely used, but it's just so amazing to see and to use, etc., which is a contains operator. So suppose you have, I don't know, whatever. You have your own class, like my own class. And suddenly, this can contain things for whatever reason. Either it's an actual collection, but let's say it's not a collection. You can say you can extend it with an operator function called contains. And then suddenly you can say, I don't know, contains a number, whatever. And you can say yes or no. For now, we are just going to say sure, always. And then what happens now is that you can do this. You have my own class. Oh, let's call it. Yep, my own class. And then you can say it, or actually, 0 in it. And you can actually ask, is this in that? And so you can say something like, if 0 in that, then, and it just, the fact that it uses in for contains, it's never something that I think about. But when I say, I'm like, oh, that's so cool. So, and then there's one that you probably have never seen before. It's a secret one that it's not documented anywhere. So it turns out, what if you decided, because you're smart, to create a fake collection that is just like a collection, but it's not a collection? Because reasons. Well, actually, Android does that. The sparse array, for example, it's exactly that. And you also, again, create a fake iterator that has its own methods. It doesn't follow anything from the standard collection stuff. Well, they thought about this. So the first operator, it's called Iterator. And again, it's an operator function. It allows you to return anything as long as that anything implements these two operators, has next and next. So it either has these, or it has the classic methods like has next and next, essentially. If it has them called like that, as methods and not as vals, then it will work. But otherwise, you can always do this. And what you can do with this is that suddenly you can use it in the for loops. You can iterate over this. It's completely transparent. And behind the scenes, what it does is just as you might imagine. Where are you? Where did it go? Ah, yeah, test. It just says, so Java loop, sorry, hurts the eyes, but calls this iterator function, which is the one that, does get iterator, blah, blah, blah. So behind the scenes, it creates static functions that wrap the behavior, and then just uses them like any other iterable collection just behind the scenes, which is really cool. All right. Bam, bam. Are you cooked? Okay, I'm going then. Right. Property delegates. Oh, this is a fun one. Normally they work by, having these two operators get 2 minutes. Okay, well, at this point, yes. In that case, you can go to this link. It's the only link you should probably write down today. There's nothing yet, but I will put at least the code that we've done today. And as soon as I have the video, which actually I'm recording the screen, so maybe even now, I'll put it there as well. So yeah, that's going to be the collection of all the things. And if you have any questions, I'd be happy to answer.